Alright, time for another DraftPhysics.com video presentation. Continuing with this banter in the comment section of a Physicist Michael video. And we'll get to one of his answers to one of my questions. And then I'll try to keep it subject relevant. Because, yes, there is more than one subject, frankly. There's more than one important subject in physics that, frankly, needs picking at. Needs higher resolution, needs more pixels, more photons. Anyway, this Dick Woodman, just a throwaway comment. I'll pay, please. Anyone can see what will happen. If he puts in the effort, you'll just say he failed in the task. I'll pay, there's no. I never said I wouldn't pay in advance. I mean, all I has to do is play a 5-minute video. He could respond with absolutely nothing, or he can respond with something. It doesn't matter. That will speak for itself. His response will speak for itself. Okay, I'm paying for him to look ridiculous or for him to actually make a physics argument. I mean, that's his obligation. And so, again, just more trash talk from trashy people. If, should we allow this in my comment section? If we were talking about Michael, we can just, make up all kinds of fake stories without any evidence at all that he somehow doesn't pay his bills or he doesn't own up to his obligations. I mean, just so foul. Anyway, he says, Michael, I say you charge him by the minute for exactly what? Exactly. Responding to a physics argument. Responding to somebody making a claim about the truth that you are so certain is incorrect, and you're so certain it's a foolish even mistake, and it's so easy to prove him wrong, well, why don't you just get to it? I don't need to be paid to do that on the internet. Point me to an asshole and I'll debunk him. I mean, unless he's a psychotic or retarded, because frankly that's just picking on defectives. But you probably find that entertaining. Don't let this charlatan. So again, I'm a charlatan in what way? These are just words you throw out. So you're a pedophile? I mean, is that why you call yourself Dick Woodman? Is because you're making a suggestion? Fuck. Take advantage of leaving anything up to the let's see, preposterous judgment. Is that what he said? I don't know. Who cares? So again, the simple statement is, yes, I'll pay him to respond to a 5-minute video. I'll pay him for live conversation even. I'll pay him for his time. Because frankly, his written answers are useless, just about. And his video responses are pretty much useless, okay, in the sense that he just evades the subject. So I'll point that out now. All right. And then we'll go back to another comment by White Henry when we get back on that subject. So I asked the simple question: if I eject 1 gram of material 100 at 1,000 miles per hour out one side of a spaceship and simultaneously eject 1,000 grams of material going 1 mile an hour, so it's 1,000 atoms going one way, 1 atom going the other way, and all I've done is change the ratio, so it's exactly the same momentum going out both sides of the ship, but it's completely different kinetic energies. Okay. In the opposite direction, does the spaceship change its direction? He says, if your G refers to grams of material, yeah, I mean, that's sort of the way Google wrote the grams anyway. The spaceship does not deflect. All right, so, and that's it. That's all he says. So let me just draw, okay, the implications of what he's saying, and then you try to make sense out of it. Because I can't make any sense out of it. I mean, he's basically conceded kinetic energy is absolutely imaginary nothing. It's a figment of physics' imagination. Because frankly, if it can't move the spaceship, it's not energy. It can't be defined as energy. It can't be a thermodynamic reality. All right. So the simple scenario is spaceship. And we'll do it at the top here, just so it's one of my, so it's easy to understand we're turning the spaceship. So we have the choice here, 1,000 atoms going at a velocity of 1 mile an hour and 1 atom going at a velocity of 1,000. This, okay, has 1,000 times more joules or watts of energy. 1,000 times more than this. So this has, 1 joule. This has 1,000 joules. That's the differential, proportional differential. And we're supposed to believe that if this was heat, okay, watts of heat, that I could do 1,000 watts out one side and 1 watt out the other side, and the spaceship wouldn't turn. Now, that can't be true. I mean, watts and joules are real forms of energy. Real forms of energy move the spaceship. So, it's kind of a nonsense, frankly, to sit there and tell me that this is real energy when it can't move the spaceship. Is there some other interpretation? Is there something I'm missing? So he doesn't even, take it one step further and explain how if this differential doesn't move the spaceship, that is, the spaceship is seeing mv and nothing else. That's all it's seeing. It's seeing mv. The mv says same momentum this way, same momentum that way. Okay, it adds up. It works. 1,000 to 1 is the same as 1 to 1,000 as far as mv is concerned, and the spaceship does nothing. So he's basically conceding the point that this and this are useless. They don't do anything. They have no meaning. They don't change the spaceship's reality at all. The spaceship does this. It doesn't do that. So isn't that pretty much he's just conceded kinetic energy, Ke, okay, is not real energy. Right? Isn't that... yeah. Isn't that this concession? I mean, isn't that the statement? I mean, what else can I do with this? If you can't move a piece of matter, can't be moved by your energy, then it can't be energy, right? I mean, the matter's matter. The spaceship is real. If you can't turn it with this stuff you're calling energy, then the energy can't be something real. Because real will do it. Momentum will do it. I just don't understand how he doesn't understand that he has sort of an obligation to explain. So now I have to write some second question to try to get him to explain, well, if it doesn't move the spaceship, how is it real? How is it real energy? Because real heat does move the spaceship. Real kinetic energy, whatever, I mean, real active energy, real stuff moving, does move spaceships. So, doesn't make any sense to me. Alright, so the other subject is basically the gravity argument in terms of the 9.8 meters. So first I'll do a little bit from White Henry, then Physicist Michael. So having listened to your most recent responses to the comments, I think I understand now why you aren't understanding this. No. You should understand that. Let me just write it for you, okay? Let me just do that. And then you explain to me how you understand what you're saying. How what you're saying could have anything to do with reality, frankly. Because it's sort of, I mean, I wish I could write this statement, but I mean, if you just write it the way it's supposed to be written, the actual true statement, it's 9.8 meters per 1 second. Now, why would you square this? I mean, first, why would you do it? And second, how can you do it? I mean, it can't mean anything. 1 second squared. So it's 9.8 meters per 1 second squared. Do you see how this doesn't make any sense? This is useless. 1 times 1 is 1. It can't be anything but a 1. You can't put a different number in here. This 1 is mandatory. It's not 9.8 meters per 1.5 seconds or 15 seconds or any squared number of seconds. It's 9.8 meters per 1 single second. What aren't you understanding? Let's see. So the rest is just it's just talk. It's just semantic wordplay, okay, about this idea of what a rate is. This is the rate, 9.8 in 1 unit of time. 1 unit of this specific second unit of time. 1 unit of this time, you get 9.8 of these units of distance. That's your velocity. That's what you get as an increase in your velocity. Understanding this, you think that acceleration is just a change in velocity. I don't think there's any reason to believe it's anything other than just a change in your velocity. It's a net change. This is the net number you get in 1 net second. You don't get it in a half second. You don't get this in some other increment of a second. This can't tell you what it was in a millisecond. It's not going to tell you that. Especially if you square this, then it's not even close to telling you that. Alright. Okay. Where acceleration is just a change in velocity, where it is defined as the rate of change of velocity. So it's not the rate of change of velocity. It's the rate your velocity changes. So again, this is just semantics, but I mean, this is a net second, and this is a net product in terms of an increase in how many meters of distance you cover in 1 second, and it's just an added velocity. That is all it is. It's how much velocity will be added in 1 second. So I don't know if it's worth reading these analogies. As an analogy, speed is a rate of change of position. So you can say so, but we're not talking about speed, are we? Yeah, frankly. But whatever, fine. Okay. That's how you detect something. What it is isn't what you use to detect it. So the fact that you detect a velocity by comparing 2 positions doesn't mean that a velocity is 2 positions. A velocity is actually the movement between those 2 positions. Alright, if an analogy you would think that the speed was just a change in position, you would say that I was at the 10 meter mark, then a second later I was at the 12 meter mark. So again, where am I saying that? I'm not saying you jump from one position to the other. You're clearly going a velocity from one position to the other. So, I mean, then, you know, why would I do that? My position changed by 2 meters, the speed of the change in position, so my speed is 2 meters. I'm not endorsing that, so again, that's not what I'm saying. But speed is a rate of change in position. So it really, I'm just going to argue, it isn't. It's just a change in your velocity. And that's all it is. You're just adding velocity or you're subtracting velocity. But that's all it is. So the rest of this, again, is just changing the way that's worded. There's no point. It's a forever word game. I think I've made the point. Squaring this would be meaningless. Can't accomplish anything. Can't do anything useful. Alright. So we'll go to physicist Michael's answer to the question. Alright, so I said the exact question was, is it correct that Newton's gravitational formula is in fact 9.8 meters per 1 second of velocity imposed every 1 second? So you're going 9.8 meters per second of added velocity per 1 second. Again, I have to keep saying it. It's there. The fact is the 1 is there by default, by obligation. Can't be a 0. or it wouldn't be a valid ratio. So there has to be a 1 there. All right. Imposed every 1 second, not every 2 seconds, not every 10 seconds, and not any squared seconds. There's nothing, it has to be, it can't be 9.8 if there isn't a 1 here. If you put some other number down here, it's not 9.8 anymore. That's the fact. So there is nothing you can do to this, okay, that's a valid change. If you square it or do something else or play some other game, it's not valid because this ratio has to be 9.8 to 1. And if you change something down here, you have to change what's up there. So if you want to square something, you have to square something else. You can't square this. All right. Poorly worded to the point of being misleading, whatever, with the second sentence. It's clear enough. This is what I was describing. 1 second. Newton's gravitational formula is generally referring to his equation. So you're going to speak to me of generalities. What did Newton say? Would be nice to know. I know he said 2 units of force equals 2 units of velocity, and so he didn't believe in mv squared, clearly. For the force between two mass objects, Fg equals gm divided by distance squared. So isn't that ironic? That the very thing I said is the component that's squared. That is, the part is your accruing distance. So apparently Newton knew that too. Okay, so why are you squaring a velocity? Alright, well anyway. Acceleration is the measure of how the velocity changes with time. It's just how it changes. The with time doesn't mean anything. We are always going to impose the change as something that happens in time because it's a velocity that's changing. So of course we have to pay attention to time. But the sentence should it end with acceleration is the measure of how velocity changes, period. That's what Newton said. Force equals the change in your momentum, your mass times your velocity. Obviously mass isn't changing, so it's the change in your velocity. The force equals the change in your velocity. Newton said you want to go twice as fast, you apply twice the force. For free fall on Earth, of course all of these examples are in free fall on Earth. That acceleration is 9 so he just keeps doing it. 9.8 meters per second. So it's 9.8 meters over 1 second. Not 9.8 meters per second over 1 second. Now, even if you did that, it still works, but I'm just saying, why would you do it? It's two different things, the seconds and the meters, and the ratio is already giving you meters over seconds. So why do I need this second division? So again, this whole argument is about this math trick. So I basically got him to admit that this is the actual equation. There is a 1 here. So that's the important part. And so keep the 1 there, and then explain to me how squaring makes a difference. And keep the 1 there, and then show me how you can change this number and then square it. Because you can't. Some other number has to be doing the squaring. Okay. The object will gain 9.8 meters of velocity, so this is the funny part, each second. Exactly what I'm saying. So, and that's all it gets, 9.8 in 1 second. Not a squared second, not a squared something, not a squared anything in 1 frickin' second. Here he says, but both those time units are needed. No, they're not. So you can say they are, but they're not. So it's just, they're needed because you need them to justify a kinetic energy formula. They're not needed for any other reason. Alright, for instance, since 9.8 meters per second roughly equals, well, we already know this part, I've used this. So this is the funny part, right? Because he's going to point out how the two times that end up in the division, right? He's going to put a time here and a time here. And he's going to admit that these two times aren't the same. That this hour isn't the same as this second. You know, or this second isn't the same as this second. So they're not squareable because they're not the same actual factual hunk of time. They're two different times. You can't formalize two different times by using a square. 3 and 7, okay? I can't square the 7 and do 7 times 3. 7 times 3 is different than 7 squared, and certainly different than 3 squared. Come on. All right, 22 miles an hour. Another way of writing this is G equals 22 miles an hour over seconds. So now he has hours over seconds, and he's still going to say that justifies seconds squared. I.e., the object will gain 22 miles an hour of velocity each second. Yes, which has been repeatedly agreed upon. That's all it's getting. 9.8 per second. That's all it's getting. It's in the gravity 2 seconds, then it gets 2 units of that, and it goes 19.6, and you say it got 4 units of energy. So even though only 2 units of energy went in, you're saying 4 units of energy came out. Or if it were free falling for an hour, it would gain whatever in all these cases. And in any other case where you're talking about an acceleration, it's going to be some length divided by a time divided by another time. So says you. And even if that's your logic, the two times aren't the same. How does t squared equal two different numbers multiplied times each other? It doesn't. I don't even understand why dividing is multiplying, frankly. A square is a multiplication. Why is having the numerator and denominator having the same unit in it mean that I square the unit? It's going to be the same length divided by a time divided by another time. And somehow you write that as squared. So that what he just said is, okay, it's going to be some length divided by a time divided by a time. And in SI units, the default is to use meters per second divided by seconds, aka meters per second squared. So a second divided by a second is a squared second. That's his argument. So if I divide 1 second into 1 second, I get 1 second squared, or 2 seconds into 2 seconds. So I divide 2 seconds by 2 seconds, and I get 4 seconds. 2 goes into 2 4 times. I don't know. So not much of an answer there, right? So what I'm really pushing for is just the concession, okay, that it is 1 second. It's a 1. 9.8 of these things per 1 of these things. And once you've established that is the truth, then I don't think your gameplay can continue, your little squaring game. Because a 1 squared is not 17. You know, it's not going to give you your exponential growth. All right, so probably enough of that subject. All right, so I brought up the clay thing. So this is a key moment in the history of mv squared. So these people will not talk about the history. They won't mention Leibniz, and they won't talk about the Chardolay. They won't talk about anything. So, and this is all has to do with why this was accepted, why the other equations were formed to fit with this equation. The work equation was completely created to match 1/2 mv squared. And that's when the 1/2 was actually placed in it, is at the same time, because they realized the numbers were outrageously wrong. Alright, anyway. So I asked this question, and he doesn't even pay any attention to it, like it's not a real subject. So it's a real physics subject, and he's just not interested. So even though this experiment was used, it's the entire reason 1/2 mv squared is a physics fact. This is why they believe it. This is why it survived. because it already had failed to survive the Newtonians. The Newtonians didn't buy it, and so let's just understand, it was proposed in 1668 or so. It was a year before Newton's publication, so maybe that's 78. But anyway, and it was just mv squared, okay, and it was called the living force, and nobody accepted it really. So Leibniz died. Nobody even paid to bury him. Just kind of pathetic. Totally discredited in his lifetime. And so then about 1738, we might want to say, de Châtelet knew of a guy, a Dutch guy doing experiments. He was a Leibnizian, passionate Leibnizian, and he was doing experiments with clay, okay, to attempt to demonstrate that the Leibnizian theory was true. So his objective was clearly to produce evidence to defend the Leibnizian viewpoint. And de Châtelet was also interested. She found Leibnizian theory interesting. She was tutored by a Leibnizian who actually sued her for plagiarism. So that's kind of funny. So there weren't too many of these people that actually did believe in the mv squared. 90% of science, or 99%, just like it is now, the exact opposite, believed the opposite, believed in momentum. Alright, and for good reason, I would argue, because mv squared is a free energy formula, and you have to be a wacky free energy nut to believe in it. Okay, but anyway, it's just so ironic. They're calling me a flat earther when they're free energy nuts. Oh, hilarious. So anyway, so de Châtelet did a couple of different kinds of experiments, all flawed in their reasoning. Now, and so one of the ones she published and described was the Granville, or whatever his name was, guy, because he dropped round things, round objects, into clay. Now, he didn't drop them, so they would penetrate into the clay. So the clay was firm enough and the objects light enough, all right, that this would be 4 times the distance. Okay, and so there was a very specific experiment. So these objects didn't penetrate, and he didn't measure how deep they went. He measured how displaced the crater they created is. And you can sort of understand that crater dynamics is kind of complex too, that depends on what angle things hit, and different things can change how big the crater will be from like an asteroid. But anyway, so this was the experiment. Now, I've made the simple point that obviously a circle, okay, is flat at the bottom and it's vertical on the sides, right? So it's like an arrow that's constantly changing its pitch. The pitch, okay, that it's going in is constantly changing. Now, you know how big a difference an arrowhead makes on a stick, okay? You put an arrowhead on, you get much greater penetration. So that's almost so obvious that I shouldn't even have to argue it. And what a round object is basically doing is changing the pitch. It's basically saying it gets pointier the deeper it goes. So the more shallow it goes, that is, the less you hit the surface, the more it's like a flat thing pushing. So you're pushing down into the surface, and then you have to push sideways. You have to do 2 motions. But if you can get it a little deeper, then you're doing more of this pointy thing. You're doing more of the pi pitch, and you're just pushing sideways. So you don't have to do the push down and then push sideways. So you're saving yourself a lot of work in terms of moving the molecules of clay. So clearly, anything with a little extra velocity will have a huge advantage in pushing into the clay, because it'll use more of this surface, okay, and less percentage of its will be this surface. Where the less deep it goes, it uses a lot more of this surface and a lot less of this. So this object is pushing mostly down, all right, that's what it's doing. 80% of its effort is down. This one, 80% of its effort is sideways. So this one has a much easier time moving, displacing the clay. So it's not theoretically reasonable to say, this crater is 4 times bigger. That means it did 4 times the work. It didn't do 4 times the work. So we're right back to the rolling things in velocity, which physicist Michael hasn't responded to my assertion that any time you roll it and expect friction to take the energy away, every single time you do that, it will go half the speed after 3/4 of the distance. That this part of the voyage will be the same as something going 1 velocity here, 2 velocity here. Okay, can you see that? Sort of on the edge. No, you can't see any of it. Oh, fuck. Alright, well, you can sort of get the clay thing here. So, it's not that, so just catch up on the drawing, right? I was talking here, and this is the 4 times the distance, this is the bigger crater, this is the flat surface, this is sideways, this is pointed this way, this is pointed this way, you get it, right? Alright, so, sorry about that. Accidents do happen. So anyway, so I've done the rolling distance argument. It's one of the 5-minute videos that he won't play, okay? But it's the same mistake to make. Yes, 4 times the distance looks like 4 times the work. But if you really understand what happens is, no, it's not. It's only twice the work, because frankly, the work it does here will be exactly the same as this whole thing, and the work it does here will be exactly the same as that too. The ground will vibrate a lot less when it's going fast, and it's going to vibrate a lot more the slower it goes. Because the slower it goes, frankly, the heavier it gets. So the faster you go across a scale, the less you're going to weigh. I mean, these are all logically understandable concepts, and they haven't been refuted in any way but through satire, frankly, through mocking, you know. People doing videos where they put crap on a treadmill and say it's the same thing, you know, that kind of nonsense. So, so it's an important subject, and he's just glibly going to walk away from it, you know. So I'll restate the question and the glib answer. Okay. Is using round objects to dent clay a good way to detect total energy? Maybe, he says. So, you know, right off the bat, he hasn't done any thought about, well, what's the distinction between round and square? Well, round has, you know, isn't pushing down evenly. Round isn't a linear surface. Okay. Haven't tested it myself. Is that your standard? You have to test everything yourself? So if I was to talk about nuclear bomb theory, you would say, well, I don't have any opinion on whether nuclear bombs can be made because I haven't tested it myself. Anyway. But we've got better methods now. Well, where are they? God damn, would I love to see these better methods. Oh, you mean the Ajax science company that gives you a 40-cent spring to do your experiment with. Yeah, the 40-cent springs are so much better. Amazing. Better methods now anyways that have repeatedly demonstrated. So again, where have they done this repeated part? All I've seen is exactly the same thing done over and over and over. What I haven't seen is you showing a Newton's cradle doing it. What I haven't seen is you showing objects without springs on it doing it, because they should by your own theory. Anything really elastic should be able to reproduce the results. Well, how come it doesn't work? I mean, come on. Repeatedly demonstrated the concepts of conservation of energy. So he says he calls it conservation of energy when clearly it's just a denial of an absolute fact. So I guess I have to ask him this question. Do you understand that total momentum and total kinetic energy can never be both conserved if I move energy from a light object into a heavy object, or a heavy object into a light object? I cannot conserve both. It's impossible to do. That's what the squared function means. That the mv and the square make the mv and the square incompatible if I change the mass. Jesus. Anyway, so the other question I asked, are you saying that Isaac Newton misunderstood the physics of motion when he said 2 units of force will cause 2 units of velocity? And he says no. Now, does that make any sense? Leibniz said he was misunderstanding. So the guy who invented mv squared was clearly saying Newton misunderstands. Clearly saying that's not the way it works. 2 units of force is 4 units of energy. I mean, that's Leibniz's opinion. Just amazing. No, but you're missing important parts. There's no other important part. It's such an explicit statement. You want to go twice as fast, twice the force. You want to go 3 times as fast, 3 times the force. He went that far. I mean, he went to the bother of making sure you understood by saying 3 times, 3 times. You know, just so you wouldn't be confused that he just meant it only happens when you double. No, he was saying 3 times the force, 3 times the energy. He was overtly saying it as explicitly as he could say it. Alright, such as saying those forces are acting for equal times. It doesn't matter, they're net forces. It's a net amount of motion per a net amount of time. So it's a complete clump of. In a clump of. There is no ambiguity about what you're getting in very specific units. 1 second is a specific unit. 1 meter is a specific unit. Okay, well, anyway. Acting for equal times and then double the force causes double the change in velocity. So I don't even know how you can even interpret this sentence. Such as saying those forces are acting for equal times and then double the force causes double the change in velocity. Yeah, that's what Newton's saying. And you say it's double the force, quadruple the energy. That's what mv squared means. Okay. And this is because double the force causes double the acceleration. Double the force causes 2 units of acceleration. 2 units of force. The force is being applied per second. There's 2 units of time. So it's 2 units of force. There's 2 units of acceleration. Rate of change of velocity with respect to time. So if it is double the acceleration for the same time, what does that even mean, for the same time? How do I double the acceleration for the same time? How does that sentence make any sense? So, if it is double the acceleration for the same time, what do you mean, what same time? It's 9.8 per 1, and then it's 9.8 per 1. That will be double the change in velocity. So he still says that will be double the change in velocity. Double what? Twice, you mean? See, Newton made it clear. That's why he did the 2 and 3 thing, is to avoid this double nonsense. This isn't about some doubling nonsense. Okay, clearly he's saying it's not 9 times the fuel to go 3 times as fast. He's clearly saying that's not true. He's saying 3 times the fuel equals 3 times the velocity. That's his clear statement. So this isn't about some double thing where you're going to pretend something's doubled. So again, is this a responsive answer? He's saying Newton didn't misunderstand, even though Newton was overtly denying the existence of mv squared. Overtly saying it doesn't happen. 2 units of force, 2 units of velocity. I mean, where's the honesty here? Alright, take a pause. I'll see if there's anything else that has been published. Alright, so, well, the added comments are really quite useless. So, the John Sean Walker, 3 names, kind of gay. Anyway, it's just so bad. So, this is the kind of stuff, you know, that people should clean up in their comments section. Because again, is this what you want in the future, physicist Michael? Is people wondering about your sexual orientation or something? And doing this kind of stuff. So he says, overestimate Goofy's mental capacity. And then he says, she, seldom can read a paragraph. Is this really, this guy is going to tell people what their sexual orientation is? Or their identity, what they identify as? He's going to tell us. You're going to let him do the assigning. I mean, it's just so... It's not, this isn't about politically correct. It's just about fucking childish. This kind of childish name calling. I mean, come on. You can't clean that up? Alright, and then this moron isn't any better, right? Okay. In the name of sanity, please stop indulging DraftScience. He is a textbook crank. And yeah, right. I make it as easy as I could possibly make it for you to show me wrong, and you won't do it. Oh, amazing. 5-minute videos. All you have to do is play the 5-minute videos and show where I'm a crank, or I'm wrong, or I've said something inaccurate that you can demonstrate with a piece of proof to be inaccurate. Alright. Who will never accept he is wrong, and I'm wrong, and why should I accept it? It's not 9.8 meters per 1 second. That's not the absolute fact. The fact is, Newton didn't say twice the velocity, twice the force. 3 times the velocity, 3 times the force. That didn't happen. Those are lies. Leibniz didn't believe in solitons. Right. He is occupying time to relieve his boredom. So we need this kind of bullshit in a comment section. This complete waste of time. Why don't you tell him to take his medication? I mean, it's so fucking bad. And so even though physicist Michael actually ended this particular video by saying, could you comment reasonably and politely? No, they can't. Okay, so they can't follow the simplest of instructions. He shouldn't be wasting all of yours. So it's, again, don't explain your theories. Just cover up anything that makes them look weak. Just pretend. It's all about just pretending. Okay? Don't deal with the counter arguments. Try to put them in jail. There is nothing anyone can say, no matter how well explained. And so why don't you just well explain why you don't have a single piece of evidence showing anything doing any of this work, this extra work, this kinetic energy, extra energy work. It can't even move a spaceship. Physicist Michael's conceded that even though I have 1,000 times more energy, it can't do anything. That will break him from his path he is on. He is worse than a flat earther. Right, and you're worse than free energy nuts. You're worse than, I mean, they just fake things all over the place, He is a, whatever this is, earther. A triangulator earther. He needs his argument to sustain him, so more nonsense. Around and around till his end. I have spent my whole life arguing with the establishment that's a moron. I mean, we basically have a constitution that's a wooden outhouse because they haven't fixed it in 250 years. I mean, everything in our culture, there's all this stuff that's insanely inefficient and broken, and all of you people just don't want anybody to say anything about it. Google promised us, right? Google said, we need a non-commercial alternative to the current search engines. Is Google a non-commercial alternative? It has now officially put ads on the homepage, right? The first couple of answers you get are ads, paid placements. The exact thing they said was horrible for the internet, they're now doing as a monopoly. I mean, you people are pathetically stupid. To make this go on indefinitely, he has decided that his intuition trumps everything. So again, it's not intuition, it's 10 years of hard work. 10 years of researching and thinking and drawing and taking notes and making diagrams. So it's just a big fat lie that I just sat and said, oh, it doesn't feel right. That's not it. I mean, of course, that's how it started in the 7th grade, was me saying, that doesn't make any sense. That squiggly line they drew for a photon? No, sorry, no sale. Photons ain't that smart. Snakes have a hard time being, doing perfect snake movements. How can a photon do it? All right. If he can't imagine a concept or draw a picture of it on his whiteboard, it doesn't exist. Well, I'm saying you should be able to model just about anything. Why not? I mean, you can, they put holograms in movies, and you can see the little hole, they model it. Yeah, sure, it looks like how it would look. You will never be able to get past that. Not in 1 year, not in 1,000. So he's too much of a coward to play a 5-minute video. And you think he's going to spend a year working on anything? We're still waiting on the lever experiment, for fuck's sake. But anyway, best thing to do is stop engaging. Okay, that's what we'll see. I'm just saying I don't think it's the best for his future, but he can go ahead and do whatever he chooses. I mean, I'll just keep making my point that clearly I've offered to pay him. I've offered to, correct whatever horror he's had to endure by interacting with me, by compensating him with real money. And he can name his price. I mean, maybe I won't pay it, but he can name it. And it's all public record. So again, what can I show anybody? You can't link to anything. You can't link to any establishment physics, can you? Can you show me some example? Look, the whole conversation is over as soon as you show me somebody pouring 9 times the fuel in the tank to go 3 times as fast. Or if you show me something going 3 times as fast doing 9 times the work. So, I mean, show me a bowling ball, an 8-pound bowling ball doing twice the work, okay, of the 16-pound ball. Show me that happening, all right, and the argument's over. But you don't have any evidence. None. Nothing. Zero. Nada. All right, leave him to the handful of people who enjoy watching him repeat the same dogma 3 or 4 times a day. Yeah, the same unresponded to dogma. The same statements, I keep saying them, 9.8 meters per 1 second, and they refuse to explain how that's incorrect. Because they're overtly saying it's incorrect. I mean, people are so dishonest. So there are some new comments in here. Thought experiment. So instead of just doing 9.8 meters per second, he contrives a thought experiment. So it says, consider a car that is initially stopped, but with a speed that increases by 2 meters per second every second. So why not just drop something in gravity? I mean, why bother with this? Let's just change it to 2 meters a second. That'll fix everything. So yes, as Galileo also pointed out, it doesn't matter which ratio, what speed you use as the 9.8. It could be 6.8, it could be 4.8. You could do the experiment on the moon, and you'll get the same quadratic increase in the distance. And it's a quadratic increase in the distance. So he keeps pointing out this distance, meters. The distance quadratically increases. And then he says, see, doesn't that prove that it's time? No, it doesn't prove that it's time. The fact that you could square root the distance or square the time, which one is actually the thing that the experiment is actually doing? The thing that's actually quadratic is the distance. Squaring the distance is the real thing. You're using something that's only associated, okay? In this particular case, the two are connected in free fall. Or in a constant force with a car, which is almost impossible to duplicate. But anyway, and that's it. So what formula is more legitimate? One that uses the square root of the total distance, or the one that squares the time. And again, it doesn't matter because it doesn't change the fact that it's 9.8 meters per 1 second. Just like right up here, it's 2 meters per 1 second. Not every second, every 1 second. So where's your square here? Why don't you write 2 meters per second squared? Why don't you write that, and then I'll say it's 2 meters per 1 second. It's not any number of seconds, it's only in 1 second units. There's a 1 here, you just didn't write it. And then play your squaring game. It's just, how many times do I have to say it, right? And say Brozo says, I wonder whether you can, I wonder whether, oh, is that the wrong weather? You can still expect that Christmas gift Gary promised. So I didn't promise anything, so I obviously made a joke, a light, humorous little statement. And so again, he's taking that, those are all formal contracts. So every time you say something, lighthearted like, boy, you'll be my best friend for life, that means you're actually signed a contract that you have to be best friends for life. It's just too ridiculous. So anyway, yes, I was happy that he was going to do the lever experiment, but what exactly has happened? What do we have so far? Oh, that's right, we don't have anything so far. Springs and bending, okay? We don't have what I argued for, which was the first experiment you have to do is figure out how much your lever is wasting. And then you can do the real experiment once you know how much you're losing to the lever itself. And then, as I've already pointed out, the better experiment, frankly, is to modify it and do the catapult thing. So all he has to do is put a rubber band on it, and launch the objects instead. And that way you can get rid of all the waste problems. Is there a point in clicking this reply button? No, there's no point. Okay. Oh, man. I do hate this planet. Nothing but creeps and shitheads. It's just amazing. Amazing the low percentage of, minimally decent humans on this planet. Just amazing. Alright, till the next time and such.